Hi, today I'm going to talk to you about three different types of events in dealing with probability. There are independent events, mutually exclusive events, and collectively exhaustive events. Now, before I go directly into these, I'd like to give some definitions. The first one being probability. Probability is the measure of the likeliness that an event will occur. This happens throughout the world, such as the probability that my car will get a flat tire if it runs over a nail. The next I would like to give to you is independent events, which is the occurrence of one outcome does not affect the probability of the other. This could be like tossing a coin and rolling a die at the same time. The tossing of the coin will not affect the number which rolls up on the die. Next, I will talk to you about collectively exhaustive events. All of the possible outcomes of some event encompass the entire range of possible outcomes of that event. So this could be such as rolling a die again. There's numbers 1 through 6, and if you roll a die, you can only roll those numbers 1, 2, 3, 4, and 5, and 6. And the last definition I'd like to give is mutually exclusive. And this happens when any two events that cannot occur at the same time. For instance, if you flipped a coin, you can only get heads or tails. You cannot get heads and tails. So when can these events occur at the same time? Well, there's actually only two situations which this is possible. One is mutually exclusive and collectively exhaustive events can occur at the same time. This could be used the same thing as the die example, where you can't roll a 2 and a 1 at the same time, and all the possible outcomes are on that die, 1 through 6. The next event, or the next instance, is mutually exclusive and independent. Let's say that A and B are two random events. They are mutually exclusive if the probability of A and B add up or equals 0. They are independent if the probability of A and B equal the probability of A plus the probability of B. Those are definitions within probability. Therefore, if the probability of A or B were equal to 0, then events A and B can be mutually exclusive and independent. Which is which? So I want to ask three different cases, and you tell me which is which. Which of these definitions relates to the word, the origin? So any two events cannot occur at the same time. What would that be? The occurrence of one event does not affect the probability of another event. Which is that? And lastly, all the possible outcomes of some event encompass the entire range of all possible outcomes. So number one is the definition of mutually exclusive. Number two, the occurrence of one event does not affect the probability of another event, happens to be independent. And lastly, number three, all of the possible outcomes of some event encompass the entire range of possible outcomes, happens to be collectively exhaustive. Now, I'm going to give three examples, and you need to tell me, are these events independent, collectively exhaustive, or mutually exclusive, or in those two specific cases, more than one? So number one, tossing a coin and rolling a die. Number two, two events. Event one, getting an 8, and event two, getting a king from a card that is drawn at random from a deck of 52 cards. And lastly, flipping a coin. So the first one, tossing a coin and rolling a die at the same time, would be independent. The outcome of one does not affect the other. Number two would be mutually exclusive, because you cannot pull an 8 and a king at the same time. There is no 8 king card. And lastly, flipping a coin. It is collectively exhaustive and mutually exclusive. Now next, I would like you guys to create 5 different examples. 1, a mutually exclusive example, a collectively exhaustive example, independent example, 1 example that is mutually exclusive and collectively exhaustive, and 1 event that is mutually exclusive and independent. Give you some time for that. And just to wrap up, these are the 3 definitions again with examples. So mutually exclusive, 2 events cannot occur at the same time at all. Just like I said before, flipping a coin, you cannot have heads and tails at the same time. Collectively exhaustive, all the possible outcomes of an event are in the range of possible outcomes. The example of a die where the numbers 1 through 6 on the die are the only possible outcomes of a die being rolled, of a 6-sided die. And lastly, independence. An outcome of an event A will not affect the probability of some event B. This would be like flipping a coin and rolling a die at the same time. The coin being heads or tails does not affect the number that is turned up on the die when it is rolled. Thank you.